Today, I'll be talking about reactance, specifically with capacitors and inductors. So, reactance is the resistance to alternating current flow. When you have an AC circuit, the current is constantly changing directions, and there's a resistance that goes back into the system when this happens, and that is our reactance. So, the reactance of a capacitor, XC, is defined as 1 over 2 pi Fc, F being our frequency, and C being the capacitance. The reactance of an inductor, XL, is defined as 2 pi FL, F being our frequency again, and L being the inductance. Reactance is measured in ohms, and that's because it's a form of resistance. If we move on to some example questions here, we have a circuit with, say, a function generator outputting AC at 500 Hz with a 1 kilo ohm resistor and a 0.47 microfarad capacitor. Putting this into our equation for XC, 1 over 2 pi Fc, frequency is 500 Hz times the capacitance, which is 0.47 microfarads, and that's why we have the times 10 to the negative 6 here. This gives us 677 ohms. Moving on to a circuit with an inductor now. We have 1 kilohertz being output by the function generator, a 100 ohm resistor, and a 10 millihenry inductor. So our equation for XL, 2 pi FL, frequency is 1000 Hz, and the inductance is 10 millihenries. That's why we have times 10 to the negative 3 there. That gives us 62.83 ohms. Now, reactance can also be expressed in this form with omega. So 1 over omega C for the reactance of a capacitor, and omega L for the reactance of an inductor. This is because omega is defined as 2 pi F. This is useful for when you're given the equation of voltage or current, so I'm using voltage in this case. Voltage at time t equals the amplitude A times sine of omega t. So we can just use this value for omega to calculate our reactance. This is another way of finding the reactance of a capacitor or an inductor. That's all for today. Thanks for watching.